how to use Pythagorean theorem. Okay, you use that when you have a right triangle, you know two sides, and you're looking for the third side. We learned about geometric means. Okay, when to use that. We learned about 30, 60, 90, and 45, 45, 90. Okay, today we're going to learn how to take care of all the other situations. If you can't use Pythagorean theorem, if you can't use geometric means, if you can't use 30, 60, 90, or 45, 45, 90, you can use trigonometry to solve your triangle. Okay, and so trigonometry is the study of triangles. There's a whole class in college that's dedicated to trigonometry. There's a semester over at the high school that you can take that's dedicated to trigonometry. It comes from two Greek terms, trigon meaning triangle and metron meaning measure. And a trigonometric ratio is a ratio, which is a fraction of the lengths of two sides of the right triangle. And we're going to talk about three of them. It's the sine, the cosine, and the tangent. That's what we're going to talk about in here. There's three more, but we're only going to talk about the sine, the cosine, and the tangent. Okay? All right, now, you see this little acronym right here, SOHCAHTOA. I'm going to tell you what that means here in a little bit, but you're going to need to memorize that. That's something that you're going to want to write at the top of your paper when you get it to take your test. Okay? SOHCAHTOA. All right, now, we're going to first talk about how to set these ratios up, and then we're going to talk about how to use those ratios to find the missing parts of the triangle. But it's important first to know how to set it up. Okay, now we're going to talk about sine first. Okay, to find the ratio for sine of an angle, it's the leg opposite the angle over the hypotenuse. Now, when you use sine, cosine, or tangent, you always use it in terms of an angle. Those are like a pair. They stick together like glue, the sine and the angle. Then you set it equal to a ratio. And for sine, it is the leg opposite over the hypotenuse. So you come over here to A, and it's the leg opposite over the hypotenuse. Okay? And so the leg opposite is BC, and the hypotenuse is AB. You could do the same for the sine of B. You come over here to B, okay, and it is the leg opposite over the hypotenuse. So the leg opposite is AC over the hypotenuse, which is AB. Now, let's say that I gave these values. Let's say 3, 4, 5. Okay? So the sine of A is opposite over hypotenuse. So that would be 4 over 5. The sine of B would be 3 over 5. Now, this ratio has a special relationship in your calculator with sine, cosine, or tangent, in this case sine, that allows you to find what the missing angle would be. Okay? And we're going to talk about how to do that. All right? That's how you got to learn how to set it up first before we can talk about how to plug it all into your calculator. Okay? Here's another one. This is cosine. Okay? When you deal with the cosine of an angle, it is the leg adjacent to that angle over the hypotenuse. So if we're going to do the cosine of A, it is the leg adjacent over the hypotenuse. Okay, the leg adjacent, which would be AC, over the hypotenuse, which would be AB. If I was going to do the cosine of B, it would be the adjacent leg over the hypotenuse. And the adjacent leg is BC, and again, the hypotenuse is AB. So again, if I gave these values, we'll just stick with 3, 4, 5. Okay, if I give those values 3, 4, 5, your cosine of A would be 3 over 5. The cosine of B would be 4 over 5. Then the third trigonometric ratio is tangent. And when you talk about tangent, it is the leg opposite the angle over the leg adjacent to that angle. So opposite over adjacent. So it's opposite, which would be this, over adjacent. So my opposite is BC over the adjacent, which is AC. Or if you looked at the tangent of B, its opposite is AC over its adjacent, which is BC. So if I gave those sides values, we'll stick, like I said, with 3, 4, 5. The tangent of A would be 4 over 3. The tangent of B would be 3 over 4. So back to my SOHCAHTOA, how is this going to be helpful to me? Well, if I can remember this, it helps me set up my ratio. Okay, my sine, the sine of an angle, is my opposite over my hypotenuse. The cosine of the angle is adjacent over hypotenuse. And the tangent of the angle is opposite over adjacent. So if I can memorize that, that's going to help me set this up, okay? All right. So again, we have another triangle. Here's another triple here at the 8, 15, 17. We want to find the sine, cosine, and tangent of R, and the sine, cosine, and tangent of S. They want me to express each ratio as a fraction, and you need to reduce it, and as a decimal to the nearest 10,000th place. Okay, so that's what they want me to do here. So I'm going to find the sine of R, the cosine of R, and the tangent of R. Alright, so the sine of R, sine is opposite over hypotenuse. So what would that ratio be? What? 8 over 17. My opposite is 8, my hypotenuse is 17. So that's 8 over 17. Then I'm going to just divide that out to get the decimal equivalent. Now make sure if that fraction can be reduced that you reduce it. 8 divided by 17. And that's 0.4706. What would the cosine of R be? Here's R. It's adjacent over hypotenuse, so it would be 15 over 17. That cannot be reduced. If it could be, I would need to. Remember, no radicals in the denominator, no weird stuff, okay? 15 divided by 17 is 0.8824. And the tangent of R, what's the tangent of R going to be? 8 over 15, because it's the opposite leg over the adjacent leg. Okay, 8 over 15. And that would be 0.5333. Okay, so now we're going to do the same thing with sine. We're going to find the sine of S, the cosine of S, and the tangent of S. So you do that one. Try that one. Do that one on your own real quick. All right, this is what you should have gotten. Sine of s is 15 over 17, which is 0.8824. Cosine of s is 8 over 17, which is 0.4706. And the tangent of s is 15 over 8, which is 1.875. Has everybody got that? Anybody need help with that? Okay, so that's how you set it up. Now, why are we doing this? How is this going to help you? Well, I'm going to take you back in time to when I was in high school, and we didn't have all these fancy calculators. We did have the scientific calculator, but it wasn't as advanced as what you have. What did it say about the sine of r? What was the decimal for the sine of r? 0.4706. 0.4706. Okay. All right. So that was the sine of r. Back in the day, we could find out what the measure of angle r is knowing that. Okay. And see here, this is a table where it's got the angle, it's got the sine, cosine, and tangent, right? And so since I did the sine of r, you said it was 0.4706. I would go and I would try to find 0.4706, or at least the closest thing I could get to it, which is going to be about right here, okay? 4.4695, so it's about 28 point something degrees, okay? That would be what that angle is. What if I had used the cosine? What was the cosine? 0.888. So see, if I went under the cosine one, it's 0.8829. So it too, you could use sine, you could use cosine, or you could use tangent. You just have to make sure you're under the right table. Okay. This is how we used to have to do it to find our estimation. Okay. Now, we have these other calculators now that does it all for us, but we have to set it up. So that's what we're doing right now, and then I'm going to show you actually how to set it up. Okay. But before I do that, I've got one more thing to show you, and this is how you can relate in your 30, 60, 90, and 45, 45, 90. Okay? It wants us to use these special right triangles to come up with the decimal and fraction equivalent for the 30, 60, 90, and the 45, 45, 90. Now, when dealing with 30, 60, 90, they don't give us any side links here, right? But when dealing with it, what is everything in terms of? The long, the short, or the hypotenuse? What's it in terms of? The short, right? So you would let the short be x, which is across from the 30, and then the hypotenuse is what in regard to that? 2 times x, and then the long is radical 3 times x, right? In your 45, 45, 90, everything's in terms of the legs, right? They're both x, and then the hypotenuse is radical 2 times that, okay? All right, so they want us to come up with the fraction and the decimal equivalent for the tangent of 30. So we come to 30 and we want to do the tangent of 30. What's tangent? What's the thing? SOHCAHTOA, TOA. What's the TOA part? Opposite over adjacent, right? So the tangent of 30 is my opposite x over my adjacent, which is radical 3 over x. But I have to reduce that, okay? My x's cancel, and that leaves me with 1 over radical 3, but I can't have a radical in the denominator, so I have to rationalize it. And so I end up with radical 3 over 3. So my fraction is radical 3 over 3, and then I'm going to plug that into my calculator. Now, when you type it in, make sure you separate yourself or put parentheses around the radical 3 before you divide by 3. Otherwise, you'll get 1. If you get 1, you didn't type it in right. Okay? Sometimes you have to, sometimes you'll hit radical 3 and then arrow over. If you've got my calculator, you have to close the parenthesis behind the radical 3. Okay? So, if you type that in, you should get... You should get 0.5774. Everybody get that? If you're not getting it, I need you to help you because I want to make sure you're plugging it into your calculator right. we're just getting the decimal equivalent. We're not messing with tangent yet. So just type radical 3 divided by 3. Was our hand over here? No. Okay. All right. Okay. All right. So how would we do the cosine of 45? Cosine of 45. It doesn't matter which 45 we use, but what is the rule for cosine? Adjacent over hypotenuse. So my adjacent would be x over my hypotenuse, which is radical 2 over x. Again, you got to get rid of those x's. Okay, they cancel each other out, so you end up with 1 over radical 2. We rationalize, and so we end up with radical 2 over 2. And then we plug that into our calculator. And you should get 0.7071. 0.7071. Does everybody get that? Everybody good? You didn't get it? Pardon? Oh, it does say the nearest hundred. Thank you. So it'd be 0.71. Thank you. Sometimes they say 100, sometimes they do. When I was growing up, it was always 10,000. You took it out 4 places. They kind of changed it up, and I wasn't paying attention. So this one would be 0.58 over here. Okay, so what we've done so far is we have just set up the ratio, okay? We have found the decimal equivalent. We have not really messed with sine, cosine, or tangent other than to use it to tell us how to set the ratio up. Now we're going to use it in our calculator to figure out the missing sides and the missing angles, okay? All right. So here's 2 examples here. And we want to find x. So we look at our triangle, we see it's not 30, 60, 90. We can't use the Pythagorean theorem. We can't use geometric means. So we have to use trig, okay? And so we see that you look at the angle that you have, or the angle that you're looking for, and you look at what you have in regard to it. I have a 32-degree angle, and I'm looking for the opposite, and I know the hypotenuse. So you say, okay, which trigonometric ratio deals with opposite and hypotenuse? Sine. So you take the sine of the angle, and that's equal to opposite over hypotenuse. Now, the sine of the 32 is a number. The sine of 32 is a number. Those 2 things stick together like glue. You do not separate them, okay? They stick together like glue. We're going to solve this just like it was, let's say, 45 equals x over 15. If we had that equation, what would we do to solve it? Multiply by 15, right? Okay? So we're going to do the same thing up here to get x by itself. We're going to multiply both sides by 15. So in my calculator, I'm going to type 15 sine of 32, and that's going to give me my answer. Sometimes you can put a times in between the 15 and the sine. Usually you don't have to. But 15 sine of 32. And hit enter, and you should get 7.9, because it doesn't say which round to. That's 7.9 is what you should get. Okay. Everybody get 7.9. Important that you get the right answer using your calculator, okay? Everybody got 7.9? Good. Okay, let's do the next one. Okay, we have a 67-degree angle. We're looking for which side? Adjacent, and we know the opposite. So which one works with opposite and adjacent? Tangent, right? Okay, because that's the TOA part, opposite over adjacent. So we do tangent of 67 equals opposite over adjacent. Now, small problem here, my variable is in the denominator. I have to get it out of the denominator, okay? So, what I'm going to do is multiply both sides by x. And so that gives me x times the tangent of 67 equals 21. I still have to get x by itself. These two things are multiplied. So to get x by itself, what am I going to do? Divide by the tangent of 67. So in my calculator, I'm going to type 21 divided by the tangent of 67. And I should get 8.9. Everybody got 8.9? Okay, now, I am going to show you one thing that you can do, okay? A lot of times people, for whatever reason, it kind of flips them out when that variable is in the denominator. If you want to avoid that, what you could do is use its complementary angle, okay? If this is 67, this is going to have to be what? 23, right? Okay, this is going to have to be 23. So instead of using the 67 degree angle, I could use the 23 degree angle, and I would do tangent of 23 equals x over 21. Okay, and that's going to give you 8.92. Okay, because you're just using this angle instead of this one. Okay, and you're still setting it up with the right, doing the right thing, and you could get the same answer doing it that way as well. Okay, all right, now. What if the angle is what is missing? Okay, the angle is what is missing. Look on your calculator and look on top of the sine, cosine, and tangent and see how it has a little inverse button. It's got like tangent with a little -1. It looks kind of like this right here. See that? Okay. Usually to get to that button you have to hit second or shift. Okay. And so in order to find the angle, you have to use that button. You have to use that one when you look for the angle, but when you're not looking for the angle, then you use regular sine, cosine, or tangent, okay? All right, so we look at this problem here. We're looking for an angle, and you have to look at what you have in regard to it. We have the opposite, and we have the hypotenuse. Opposite and hypotenuse is what? Sine. So we take the sine of x, and that is opposite over hypotenuse. Sine of x is opposite over hypotenuse. Now, because you're looking for the angle, when you go to type this in your calculator, you have to hit second sine. You have to hit second sine, and that little -1 in the parenthesis usually opens up. And then you put your division for your fraction in there. 3 divided by 5. And you should get, and then hit enter, and you should get 36.5 degrees. Is it 8, not 5? Maybe I just wrote it down. Oh, 36.9. I think I looked at the wrong one. 36.9. Okay, 36.9 degrees. I think I looked at the wrong answer. Try this next one. Which trigonometric ratio are we going to use on this one? Cosine, because we have adjacent and hypotenuse, right? So we're going to do the cosine of x equals 7/11. And because we're looking for the angle, you have to use the inverse. So you have to do second cosine 7 divided by 11. And you should get 50.5. 50.5 degrees. Questions? Everybody get that? Everybody's getting it right on their calculator. That's the biggest part, hardest part about this is making sure you plug it in right. Okay. All right, let's do one more. Dakota is standing on the ground 97 yards from the base of a cliff. Using a theodolite, he noted that the angle formed by the ground and the line of sight to the top of the cliff was 56 degrees. Find the height of the cliff to the nearest yard. Okay, a lot of words, but not a hard problem. You have a cliff, okay, and you have Dakota, who is standing 97 yards from the base of the cliff. Now he's using this little theodolite. The theodolite measures what angle is created by the ground and the line of sight to the top of the cliff. So it's measuring this little angle here, and it says that it is 56 degrees. And it wants to know the height of the cliff. Now, in a perfect world, the cliff and the ground are going to make a 90-degree angle, okay? So we have our right triangle. So what could we use to find the height of the cliff? Sine, cosine, or tangent. You have a 33 and a 3% chance of guessing right. Tangent, right? Okay? Because you have opposite and adjacent. So we're going to use the tangent of 56 equals x over 97. What do you get? Are you going to use second tangent this time? Why not? You're not looking for the angle. You only use that when you're looking for the angle. So what you get? It says round to the nearest yard. Anybody get an answer? 144? Okay. 144 yards, because it says round to the nearest yard. Yes.